just got to get a start. So I'm not going to do much intro because Danny's talk is about 50 minutes long, other than Victor over here saw Danny present at a Groovy conference in Europe. Great. Yeah. Great. Yeah, so the great conference in Europe, and thought it was such a good talk that he actually just do it himself. So if you want to turn it around, Victor, just so Danny can see everybody. And
yep, say hello to everyone. And everyone
hey,
can say hello to. Hey guys.
All right. Yeah, I guess, you know, if we might just break for questions at various intervals, and otherwise we'll, you know, shout out and, you know, yell any questions through to you if anything comes up. Otherwise, without further ado, is Danny.
Yep.
Yeah, thanks. Good evening, Melbourne. How's everyone doing? Great.
These two guys are great.
All right, that sounds good. Okay, so my name's Dan. I'm a part of the Ratpack core team. I'm going to talk to you about Ratpack. Just a show of hands, how many of you have heard of Ratpack before? Okay, all right. This is.
I did.
This is great then. Okay, so let's talk a little bit about what this presentation is about, and then we'll talk about Ratpack as well. So in this presentation, we're going to cover how to implement a REST service, but kind of going about it in a sort of organic way. So typically when you start writing web application, you'd like to be able to quickly sketch something together to get some kind of working proof of concept. And then, you know, as that proof of concept starts to gain traction, you'd like to be able to evolve it and turn into an application that, you know, is something worthy of deploying to production. So this is a very detailed guide on how to do that. And for those who are interested, you can go into my GitHub. The name of this presentation is Ratpack, Rapid Ratpack Groovy. And we're going to go through how to sort of organically put together REST implementation. So in particular, we're going to be implementing some endpoints to be able to plug into todobackend.com. For those who are, for those of you who are not familiar with this, this is essentially backend is just a bunch of different backends that implement a common set of REST endpoints that facilitate being swapped out for using on the to-do front end. So for those of you who are familiar with the to-do front end, you know, this is a way to provide persistence and, you know, kind of demonstrate how your framework works. So at the end of the day, we're going to, well, I have a application deployed to Heroku right now. And as you can see, we have some stuff in here. This is my application running right now. This is what we see at the end of the day, but the final product looks something like this. So you go to backend.com, you plug in the base of your application where it's hosted, and there are a couple of specs that run, and we'll see how this works at the end of the presentation.
Just a quick, Danny,
sorry?
just a quick note. Your font's just a little bit small, so if you are going to like refer to URLs or something, or JSON, just a reminder to make it bigger if you can.
All right, that's good to know. Okay, so to accomplish this, we're going to be using Ratpack and Gradle as our build tool, and let's get right into it. Oh, another thing is I'm going to be writing this stuff in Groovy, but the fact of the matter is Ratpack is built on top of Java 8. And so Ratpack core is written on Java 8 as well. We tend to have really good support for Groovy integration just because all the various committers are also part of the Groovy community. So we have first class Groovy support, but it won't stop you from using other JVM based languages. We have another framework that's built on top of Ratpack in Clojure. It's a really cool project. I highly recommend you check it out. And some people have done examples on how to do Kotlin and Ratpack. So if Ratpack interests you, you can go check that out at the end. Okay. So what exactly is Ratpack? So Ratpack is a set of libraries that allow you to write reactive, non-blocking, asynchronous web applications. I know that kind of doesn't mean anything. Writing asynchronous web frameworks, they're a dime a dozen, and it's like, why do we need another one of these things? Well, so Ratpack kind of takes all these lessons learned from big, full-featured, full-stack MVC frameworks and kind of provides an alternative way to get the most bang for your buck, so to speak. So a couple of key features of Ratpack that I like to point out is that it's lightweight. What do I mean by that? So there are no SDK binaries to download. Typically, if you're working with a full stack MVC framework, you typically download some kind of SDK to get going, maybe have some command line tools that are there. And another thing about Ratpack is that there's no code gen. So unlike other web frameworks that maybe produce additional classes or do any kind of meta programming or something like that, Ratpack doesn't do any of that. It's pretty much what you see is what you get. Another important thing is that Ratpack is written on top of Netty, so we don't implement the servlet specification, which means we don't have any servlets. So if you have servlet filters or anything like that, you're not going to be able to use them here. Also, we don't deploy to a server container. Typically, Ratpack applications are packaged as embedded jars, and you just run them. Again, Ratpack is not a full stack. It's not MVC either. And any kind of extended functionality is provided via modules. So if you head over to the Ratpack, the Ratpack code base in GitHub, you can see that our code is sort of organized in kind of this kind of way. And as an example, if you didn't need anything other than the ability to handle web requests, then all you need is Ratpack core. But if you wanted Groovy support, or if you wanted support for Juice or H2, handlebars, et cetera, you can kind of come here and take a look at what we officially support. And then our users have also published their own Ratpack extensions, and they have them hosted on their sites. At the time, I don't think we had any kind of centralized resource to come and take a look at whatever's available in the ecosystem, but that's just something that we have to put together. But yeah, if you want to take a look at what's supported, you can come here and take a look. So we typically also do we support dependency injection through Juice and Spring Boot. And another thing is with writing Ratpack applications, it tends to have a couple of key features that we're going to go through. But essentially, Ratpack, for every kind of feature that Ratpack provides, we have test framework agnostic fixtures, right, that allow you to test about every feature that Ratpack provides. That could be its own talk, and I do have a separate talk about testing Ratpack applications and all the various features of it. So let's take a look and get started in writing a Hello World application. So I want to do this kind of live just to demonstrate how quickly you can prototype applications in Ratpack. So this is a typical Groovy script. You don't have to understand Groovy to be able to read it. This is just a grab annotation that you apply in your script. And as you can see, it kind of uses these Maven coordinates. So we have our group artifact version up here. And the only thing we need right now to do a simple hello world is to have the static import to Ratpack Ruby. This is made available when script runs. So what's going on here? This kind of looks like magic, right? So what I'd like to do is just get this running. We invoke the script. It'll take a little bit to download everything if you haven't done that for the first time. So if you find that your script is running for maybe 2-3 minutes, it's probably still downloading all the dependencies. And then once we're done, you should see this message here that Ratpack is up and running. It's bound to port 5050 on localhost. And if we issue a curl for this, we see that we get hello back, right? So nothing special there. Nothing too compelling yet. It's except maybe this kind of way of defining a handler. So what's going on here? When you invoke this method, you pass it a closure, or in Java 8 parlance, just a lambda, right? And the implicit argument here in Groovy is the server specification. So this handlers method gets resolved against this server specification argument. And so handlers allows you to define your chain of handlers. We'll cover these terminologies. And then handlers here has an implicit argument of chain. And so this get method is then invoked against the chain. And then here, this is the actual handler. So from this closure right here. And the implicit argument here is the context. So when you invoke render, it's resolved against this context object. So what's going on here? We've defined a handler for the root path here against the root path here for a HTTP GET method. And what we're doing is we're rendering the word hello. So this is easy enough. You can start to see how it's pretty cheap to get started with the Ratpack application. There's not much needed in the way of getting up and running. And the overhead of starting a Ratpack application is so low that if you decide that maybe this isn't the right fit for you, you haven't really wasted much effort. But let's do something really cool here now. So, is that how you spell Melbourne?
And
so if we change this file in real time, the Groovy or Ratpack will detect that change is done, and then it'll recycle the application. And so when we issue a curl request here, we can see that we have the desired output of hello Melbourne. Yeah. Is that readable to everybody?
yep.
Yeah. Okay. Yeah. So without having to kind of recycle it ourselves, Ratpack takes care of recycling the entire application, and you get to see the changes in real time, which is pretty nice. And the reason that we can cycle the entire application is because Ratpack servers have such low overhead in terms of getting bootstrapped. So we can do that. We can define additional endpoints here. We can say, right, so if we define an endpoint for the MalbJVM group, we can define another endpoint here. We just save the file and we issue a curl against this MalbJVM endpoint. You see that we get good evening, right? So you can add, remove handlers at will. And what we could do here is also we can turn this into sort of like a dynamic handler. Again, this is an implicit context object, right? So path tokens is a method. In Groovy, if you ask for something like this, it'll actually invoke context.getPath tokens, and we can just access it here and kind of do variable access as if it were a part of the path tokens class. That's a cool thing about Groovy. So we should just get we should just echo back whatever this path parameter is. So if we were to issue another request, oh, did I save? There we go. So if we ask for MalbJVM, we get MalbJVM back. If we go for hello, we get hello back, so on and so forth. What I'd like to impress here is if we were to make a post, we'll get a 405. But that makes sense because we didn't define a post endpoint. So if we were to change this to post, we'll see that we get this back now. So, I mean, in terms of quickly like prototyping an application, you can see that this is a pretty cheap way to do it. You can kind of define the shape of your application for very low effort and get something going. So let's go through this in detail. We went over most of this stuff here. So the render method in particular, takes an object of any kind. And as long as this object has renderable support, Ratpack understands how to render it to the client. So you could create render support for any kind of object such that you don't have to worry about how it's being rendered. Another thing to note here is that Ratpack is definitely not MVC, and it's definitely not doing any kind of lookup table here. So when we're constructing our chain of handlers here, what we're doing is we're actually creating like a sort of like chain responsibility. So for this first handler that comes in, if this doesn't happen to match our incoming HTTP method and path, then the next handler gets evaluated and see whether that matches or not, until we find a handler that either responds or we run out of handlers and we don't have any way to respond to the user. In that situation, Ratpack can detect that you haven't responded to the user and send an error to the user on your behalf. So again, these notes are available on my GitHub, so you can get over there and take a look. I'll also tweet these notes out at the end of the presentation. Yep, so we went over live reloading and okay, so yeah, let's talk about handlers, right? So if we come back to this, our application definition here, closures that we pass to the methods get and post, these are the actual handlers in themselves. And these handlers, again, take an implicit context object. If we were writing this in Java, we'd expect to see, lambda that looks something like this, right? So this would kind of be how you would declare this in Java 8. So what is a handler? A handler is basically a mechanism where user code interacts with Ratpack code. So it's pretty much your servlet or your controller, depending on what you're coming from. However, in addition to handling the web request, you can also do additional pre-processing or post-processing and decide whether or not to delegate to the next handler in your chain. Another thing about chains in particular, so chain is just composed of handlers. Some more jargon I'm throwing at you. But the thing is that the chain is dynamic. So while you're processing requests, you can actually insert additional handlers into the chain in a dynamic fashion. So let's talk about starting to implement this to-do backend application. Typically, so for a requirement for this is that you need to be able to accept CORS requests, because we're hosting our application on one domain and the front end is on a different domain. So we want to be able to set our headers correspondingly such that the client is allowed to issue a cross-domain request. So when we talk about, right, so everything that you get access to in the servlet container, which is stuff like the request object, the response object, right, sessions, that kind of stuff. This is all available in Ratpack handlers from the context object. So as an example, if we were to set our headers for doing CORS operations, we would just grab that off the request object, which is, again, implicitly resolved against the context. We can ask for headers here, which returns us mutable headers. And then we just go ahead and set the headers that we need. So in this situation, we would be able to not only set the headers, but then just render a message back to the user. So if I'm, just to demonstrate that this is working, here, on this application, get out of here. Okay, so our application's up and running. Again, this is another thing. I'm used to this by now, but when you're developing Ratpack applications, you'll often find that they just come right up right away. There's not kind of a wait period where, you're going through your application and it's starting up and it's taking care of lifecycle and all that kind of stuff. Ratpack is already up by that time. So if we were to issue a curl request here, and let's turn on the verbosity flag, you'll see indeed that we are setting the CORS headers right here, and we get our message back from Ratpack. So anything that you need in terms of talking to requests or response, you'd be able to get that information from the context object. So we have that available, and here, oh yeah, so here's another thing. So here's where we start talking about evolving your applications from kind of these scratched out prototypes to more fully well-organized, maintainable applications that you push to production. So essentially, we have a bit of code. Let's see. Yeah, so this is what that looks like, right? Is that visible? Okay, so essentially we'd like to be able to organize this stuff, right? So here we go. And any kind of reusable functionality we'd like to be able to pull out so that it's easier to test, so that it's easier to read and easier to reason about. So because these kind of cores headers are not unique to any kind of request in our application, we'll pull it out into another method on our chain. So this method is all, chain.all. So this handler will run for any HTTP request and any path that you pass to it. So this runs regardless, right? And this is equivalent to this, except that these headers will be set for any kind of request that comes in, whether or not it matches this GET request here. So that's what we have going on here. Further organization, we can actually take this handler that we produced in the all and produce our own class out of it. So this is just a bit of Groovy here. We're statically compiling this class. We're extending Groovy handler, and this is the contract that you have to implement. So it's just a void handle, and you get your context here. If you're doing this in Groovy, it's a Groovy handler. If not, it's just a regular handler, and then, of course, Groovy context and context. Those are the two analogs between the Groovy and the Java versions. So we can see here that we are producing this. This is the same bit of functionality that we're doing. And what we do here is then on context, we're signaling that we'd like to continue to the next chain in the handler. So this is kind of chain delegation or handler delegation that we're seeing in action here. So you can see that the handlers can act like servlets as well as servlet filters, and kind of a combination here. So what we do is after we define this, we just instantiate it and pass it to the all method so that we still get the functionality of having this processing your request, adding the course headers, and then delegating to the next chain in the handler, which is simply issuing a hello Ratpack here. And just to show that all of this is still working, we can shut this one down. And we'll issue the request here against. I don't think I can scroll back that far. Okay. So this is Ratpack 3. We'll get this up and running. There we go. Okay, so once Ratpack comes back up in a matter of seconds, we will issue the request again and see that the course headers are still being set. And we got our message back out. So this is kind of a mini example of how you would go from, scratching out your functionality here and then refactoring it so that it's more maintainable for future. And of course, if we have our own handler outside of our application definition, that handler is then able to be tested. And we have testing fixtures for that, but that's a different talk in its own right. So let's get back to the slides here, or the notes here. So we went through all of this. Yeah, so we'll take a look at here is just this course handler is just a standalone handler here. And because it's standalone, it's easy to test, it's easy to maintain. So as you can see, this is pretty much the pattern that we're going to be going through. We'll implement a bit of functionality, we'll scratch it out, and then we'll reorganize it, and then put our code into kind of modules that allow for easier maintainability of writing Ratpack applications. So I hope you're starting to get the feel that in Ratpack, you kind of write your applications the way that you want. Ratpack is very unopinionated about how you do that. Unlike other frameworks that try to use convention over configuration, right? Where you kind of put your classes in designated areas, and if you deviate from that, then you have to configure it and tell it how it works. In Ratpack, everything is explicit. There's no implicit behavior here. And you're in control of how your code evolves and works in your application. And this is also kind of another value add for Ratpack, in that sometimes if you're working with a framework, you're fighting against it because you don't really know what's happening on your behalf. But in Ratpack, because you're explicitly specifying all the functionality that you'd like to have, you're in control, and you should have a better idea of what your application looks like and how it's functioning. There should be less surprises here because everything is more explicit. So migrating to Gradle, how many of you use Gradle? Just a quick poll. Okay, that's a fair number. I'm assuming the rest of you use Maven. I'm hoping nobody's using Ant. Yeah, okay, good. Well, Ratpack doesn't care. With Ratpack, since it's just a set of libraries, you just have to pull it into your compile class path, and everything will be taken care of there. So if you want to use Ant, you can use Ant with Ratpack. If you want to use Maven, that's fine. I recommend using Gradle, however, just because we have a Ratpack Gradle plugin because the project lead works at Gradle as well, so he has a very good understanding of Gradle. And if you want to do a case study of how to write and organize a multi-module Gradle application, the Ratpack project is a pretty good example of that. So I recommend you take a look at the Ratpack source code just to see how expert Gradle people write their own applications. So migrating to Gradle, though, is a pretty non-event. You just need really these two blocks in your build script to be able to get up and running. So here we specify our Gradle, we supply the coordinates here. This plugins block for Gradle users, this is a new feature from Gradle. It's still incubating, so be warned when you're using this. Yeah, you could still use the old way of including plugins, but I tend to like this because it's 3 lines instead of 10, 12 lines. And but there are some downsides, which I'll leave as an exercise to the user to figure out what those are. Another important piece is that we need this repositories block. So this just tells Gradle where to resolve our dependencies against. And in our situation, we're just going to pull these from JCenter. You can pull these from Maven Central. We publish there as well. So once we have our Gradle script, we'd like to reorganize our code a little bit. This is kind of the directory structure that by default will work. This is the only bit of convention that we have here. But if you want to deviate from this, you can specify that in your configuration to your Ratpack application, to point to where your Groovy script for your main application and your stuff lives, right? So I'm not going to bash Maven in this talk, since a lot of you are Gradle Maven users, but I really highly recommend if you're thinking it's about time for a switch, or you want something that's faster or has more functionality, I recommend taking a look at Gradle. But all that's needed to run this application from Gradle is just to invoke Gradle W. So Gradle W is the wrapper script for Gradle. This is another selling point of Gradle. I think there is a Maven W as well, but that was inspired by Gradle W. Essentially, you ship this script with you so that no matter where you're running, everybody will be running on the same version of Gradle. It's helping to reduce it runs on my machine syndrome. But essentially, we have the way that I have the code repository set up. I just named this module as example3 Gradle, and we issued the run command here. So I don't think this is as interesting, but once it's up and running, then you can issue a hello world. So another cool part about the Ratpack plugin, the Ratpack Gradle plugin, is that we can leverage the continuous mode here. So what continuous mode does is it'll start watching the files in your system, watching your file source set, and if any of those files get modified, Gradle will issue a full invocation of the task that you had passed to it. So in this situation, it was run, and by issuing run with a -t for the short flag or the continuous as the long switch, it'll rerun the run command when it detects that any of your source files have changed. So I think that's worth taking a look at. So if we were to take an example here, let's bring down this. Well, the server's not up anymore and my console's not responsive. Let's just okay, so we'll issue that. Okay, so you can see here that we're up and running. And now Gradle tells us that we're waiting for changes to input files of the tasks. And it tells us how to get out of here if we need to. So let's issue a curl. We see that that's working. So if we now navigate over to, this is example 3, go to the Ratpack script here. So if we were to change this to hello Melbourne and just come back here, you can see that Gradle kicked in. It detected that some files have changed. It figures out what tasks it needs to run. Gradle's pretty smart about that too. And if we issue a curl against here, we'll see that, we'll see that we get the response back. So not only do you get to maintain the kind of fast real-time updates in Groovy scripts, you also get this when you're running with Gradle. We don't have a Maven plugin, unfortunately. So if you're using Maven, you're not completely out of luck, because if you're using IntelliJ, which I'm guessing most of you are, you can come in here, run this as a debug configuration. And as long as you're running in the debug configuration, any changes that you make to your Ratpack application will be reflected in real time. Yeah, so the other application didn't shut down yet. Okay. Let's try that again. Okay, and we can see that the application is up and running. Same message, same set of messages that we've seen before. Just to make sure that we're up and running, we issue a curl. So now if we were to set this back to hello world, issue a curl again, we get hello world. So you kind of still get to the ability to see your changes reflected in real time, even if you're using Maven, as long as you're using IntelliJ. So you have a couple of mechanisms here that allow you to get this kind of developer-friendly feedback cycle here. So let's continue. Yeah. So this, I'm going to start flying over a couple of these just because the setup is quite intense. But what I'd like to impress upon you is that we're using, we need some kind of persistence, right? So for database here, we're just going to be using H2 for in-memory, and then we're going to be using HikaricP, which Ratpack has a module support for. This is a really, really cool project. So HikaricP is an alternative connection pooling library, and the performance of this thing is just insane. This guy is really smart as well, Brett Woolridge. And if you're not familiar with his work, you can come take a look here and take a look at how he's able to achieve such high throughput using less threads in his connection pool. It's a really impressive piece of engineering. And and I don't know how many of you have heard of Juke. It's kind of a port over from C# and from C#'s like Link, but essentially it's a way to statically write and execute your SQL. It's pretty cool. Juke requires code generation. It uses like schema information and then generates classes that have the types that match the rows in the database. So this is just some details over how to set that up, right? So we're adding Juke code generation and H2 and so on and so forth. This is just the schema, right? So to keep in the back of our minds, we're working with a to-do application. These things have IDs, titles. There's a flag whether or not it's completed, and the order, so that you can order your to-dos so they can have priority. This is just some detail going over how to get up and running with Juke. There's way more information on the Juke website. This is just pertaining to how we're going to do it. So yeah, you generate your code classes, and then at the end of the day, you end up with the file structure that looks something like this. So under source main Java or Groovy, you'll see that we have our Juke classes, and then we have our singular table here. This represents our table that we're going to be making SQL requests against. And yeah, and this just contains the SQL that we have here. So after all of that, we also added dependency on the Hikari module. Oh yeah, we should take a look at how that's done. So if we come back to the build script here, so this is something special about Ratpack. Typically, when you're working with open source frameworks, you tend to externalize the version somewhere and then kind of use that, interpolate that in your dependency definition. But another great thing about the Ratpack Gradle plugin is that it exposes this class with this method dependency. So when you ask for the Hikari as an example, because this is an officially supported Ratpack module, it knows how to generate the Maven coordinates to be able to pull this down. So all you have to say is that I want Hikari, and instead of saying I want IO Ratpack Hikari version 145. And so this helps, when you're upgrading Ratpack versions, that you make sure that all your dependencies are in lockstep with each other. Another reason to use Gradle when working with Ratpack. Okay, so let's talk about what your new application is going to look like. With this, what we're doing is we're introducing a new bindings block. With the bindings block, this implicit argument here that you don't see here is called the it's called the binding specification. And in the binding specification, you can use this to bind instances of things. We have support for juice modules. So if you have a juice module, it will take everything defined in your juice module and apply it into the Ratpack registry. We didn't go over Ratpack registries, but they are an important concept. They're essentially a data structure that you use to communicate between handlers, right? Because you can specify handlers in this kind of way in a chain, and you don't want to have any kind of global objects that you're talking to. You essentially have a registry that you can add items to, and then down the chain, you can grab items from that registry. It's also important to note that the context object, which is the implicit argument here in these closures, the context itself is also a registry. So you can add items to your context registry and pass that down the chain, which allows you to organize your code in a better way. So if you do any kind of pre-processing up front, like course handler, or if you're doing authentication or authorization or anything like that, you can extract all that logic into reusable code that calculates results and then puts them into your context registry, and then you can grab the results of those computations further down the chain. So that's the mechanism by which we recommend that people do this. But yeah, there's nothing special here. We're just setting our data source class name. We're just specifying H2. And we're telling it that when you start up, please execute the schema that we've defined in init.sql. So when this gets up and running, we have access to everything that we need. Okay, so here's the first bit of meat in regards to implementing the to-do backend. So here's an example of using Juke. The details of the Juke part are not important. It's just the fact that we're issuing a blocking call. Way on earlier in the presentation, I had mentioned that Ratpack is a asynchronous and non-blocking framework. Now, I have another presentation that dives into the kind of like a high-level view of how asynchronous behavior works in Ratpack. And essentially, for any kind of request-taking thread, which will be here, you want to make sure that you don't block this thread. Otherwise, you won't be able to accept any more NIO events on that particular thread. By default, Ratpack spawns 2 times n threads, where that's the number of n is the number of CPUs available. This is just a number that the Netty team has organically arrived at by just testing a whole bunch of different configurations. But essentially what we're doing here is this get is actually being resolved against the context, the invisible context here. And we're passing it a class here. So we'd say we'd like to grab any data source that you have in the registry. And we happen to have a data source because of the Hikari module. So because of this connection pooling, it provides data sources that we need. So we get the data source here. We pass this and specify that we're speaking H2 here, the DSL. And so from here, you can see that we're selecting star from to do, and then we're going to invoke fetch maps. So this will grab everything and return them as a list of maps to you. And then what we want to do is represent this as JSON. So we have a Jackson static method JSON that will turn this list of maps into a JSON renderable, which we then pass to the rendering framework. Now, you should never do this. Don't deploy this kind of code into production, because this fetch maps is where the blocking JDBC behavior happens. So that's the thing about the Java ecosystem, right? Is that most libraries that you're using are written in a blocking and synchronous kind of way, and Ratpack understands that and provides a bunch of facilities for allowing you to integrate blocking libraries with your application. It also provides facilities for integrating other asynchronous libraries into your application. So if you're using something like RX Mongo as an example, we also have RX support. We allow you to bridge the executions from the Mongo library into ours. And that's another talk in itself, but I'll go over how to make sure that you're not blocking the main thread when you're making these kind of blocking calls. So our first facility here is blocking.get. This is a factory method that produces a promise. So Ratpack promises don't behave the way promises work in almost any other language or framework or library that you've ever used. The important thing that I want to impress upon you here is that promises are lazy. They don't get evaluated until you subscribe to them. And the subscription happens through promise.then. The order in which you declare promises are the order in which they execute. So when you declare a promise, they may not be issued straight away. Instead, every time you create a promise, it queues what is known as an execution segment, which means that when you're working with asynchronous code or blocking code in Ratpack, your promises get queued up and then they get executed in FIFO order. So this is another value add about Ratpack. And there's a detailed set of articles by Luke Daly of Gradle fame. He's also he's on the Easterns. He's from Queensland. He's living in Brisbane, but he has a bunch of articles here talking about how the Ratpack execution model works under the hood. So another important thing here is that it makes promise. This means that the promise execution is deterministic, which is something that's nice when you're working with asynchronous code, because working with asynchronous code is a nightmare. You don't know when things are going to come back. You don't know what kind of error handlers are going to be invoked, and Ratpack provides all these ways to manage your asynchronous behavior such that you'll always be able to continue with your flow or do whatever you need to do, provided you come back in and hook back into resolving that. And another thing that I'd like to point out is that because we queue up all our execution segments, if by the time Ratpack runs out of execution segments, meaning that you haven't specified any more code to deal with Ratpack promises, Ratpack recognizes that and is able to terminate a connection to the client, saying that, hey, the user or the developer ran out of processing code and doesn't have anything more to say to you, so let's terminate the connection with the 500, or yeah, with the 500. And that's a feature that you don't find in any other asynchronous web framework, is the ability to detect when asynchronous activity is no longer going to happen. And Ratpack understands that. So we have dangling request as a detection as a feature. So if you're used to working with something like Node.js, where you fire off an asynchronous action and it comes back and maybe you forget to send a response, if you issue a request against that endpoint in Node, it'll just hang there. But if you do the same thing in Ratpack, it'll quickly terminate and let the user know that there's some kind of error happened. So let's fix our code block here so that we're Ratpack compliant, that we're not blocking the main thread. So we have everything that we have from before, except that we've isolated the fetch maps in the block and get facility. So this produces a promise whose type, I didn't include it here, I should have. The type of this promise is of list of maps. So that's the generic information here. And then this is the important bit. Unless you invoke then, which subscribes to the promise, you'll never be able to respond back to the user. So here, when we resolve our value, we'd like to turn that into a JSON renderable and pass that to the rendering framework in Ratpack. So that's what this bit of code does here. And this will be the basis for going through the rest of and implementing the rest of our application here. So code cleanup, right? I'm just going to fly through these. I won't necessarily prove that each of these work. But again, all the code is available, so you can verify this for your own understanding. But this will be the basis for implementing our CRUD endpoints, and we'll be reorganizing the code in such a way that it's more manageable and easy to reason about. So when we do a bit of refactoring, what we're going to do is just create a to-do model that represents in a strong typed kind of way what a to-do should look like, and we can map these to fields that we have in our database. So there's nothing interesting here. There's just a couple of methods that kind of factories here that allow you to. This is just for kind of ease of working with the to-do here. It's not necessarily required. Okay, so that's select star, right? What we're going to do is we're going to create our own kind of to-do repository here, and what we're going to do here is just essentially create. This is our constructor, so we're expecting to grab a data source, and we're going to generate this DSL. This DSL here, which allows us to create and issue queries. So the start of this to-do repository is just with the get all, and the get all we're just going to create from doing this bit, and then we return the blocking promise, right? So from all, we're gonna grab everything we can from the database and then just issue the transformation into this to-do model class here. So this will be where we house the rest of our CRUD functionality against the database. So another bit of reorganization is if you have a bunch of these kind of services or collaborators that you need and they have dependencies, what you can do is you can set them up in a module. And in the module, since this is Juice, and if you're not familiar with Juice, this should be pretty readable. It should read like Spring Java configurations. But essentially, you just say that this is a singleton, we get a data source, and this is how you produce a to-do repository. So you can just ask for it instead of constructing it yourself. And then the way to register this module is to just add another module in the bindings block. So what the cleaned up code ends up looking like is like this. So because we've added the to-do module, which contains the registry, which contains the to-do repository, we can then grab it out from the handler and make the request here. So this will produce the promise from which, when the promise is resolved, we're able to render all the to-dos that we have in our database. So this is just for select star. We have, again, like other implementations that we go through in a pretty detailed and verbose manner here. And since I think that kind of right. So here's another version of the repository where we have get by ID, add, update, so on and so forth. Operation is like a promise type void, which means it takes a null and it returns a null. But since we don't care about any kind of since we don't care about the value of the computation from the result of this promise, there's a specific type here, operation, that just represents some asynchronous behavior that will then be resolved at some point, and we don't care what the result of that is. So these are situations typically maybe when you're deleting something, or when you're, I guess deleting is what we have here. Yeah. Yeah, so what does this look like, right? When you come back to our Ratpack script, and again, everything that you can do here, you can do in Java as well. You just have to add back in your implicit, you have to turn your implicit arguments into explicit ones. But then you just spoke, as an example, like server spec.bindings, and then here you would have your binding spec.module.module. But yeah, you can see that we have a new module here, and you can see that we're starting to shape our CRUD functionality in terms of REST. So here's our REST endpoint that gets select star, right? So once you have this going, we can talk about reorganization. But first, a word about JSON. I touched on this a little bit before, but essentially, we have the ability to parse objects from JSON and render them to JSON, to the client. So if we were to receive a request as JSON, which is a typical work case and workflow in REST applications, we can actually So this parse method is being invoked against context. And since the context contains the request body, the parse understands that we're reading the request body and we'd like to turn it into a to-do model. And we're using this from Jackson to hook into the parsing framework within Ratpack. So Ratpack has kind of two sub-frameworks within it. One is for parsing and one is for rendering. The parse is kind of the opposite side of rendering. So if we were to define an endpoint that accepts post JSON objects and then we save them, this just shows you how we can grab and transform into our strong Java class so that we can work with it, essentially. So this is just to demonstrate that we can parse incoming JSON in a fairly straightforward fashion and prove that we have the result here. So just some sample output here is when we issue a curl request against this endpoint, we get the title back, right? That's what we defined up here, is we're just rendering the title back to the user. So to get this back into our repository now. So here's another thing about Groovy. If you're using Ratpack and Groovy, you can explicitly name by type any kind of dependencies that you have for your handler. And Ratpack will grab this from the context and make it available to you within the scope of this closure, which is pretty nice. You have the support in Java as well. It just ends up being a bit more verbose. But I like how this reads. So we can see that instead of calling context.get to do repository, as we did in the previous example, we can just define it up here, and we're able to work with it in here. So essentially, we're parsing from, since parse returns a promise, we have that. We don't really need this bit since we're subscribing to it in this kind of fluent manner, but we'd like to parse this, invoke repository.add, take the result of that, turn it into a JSON renderable, and then call context.render. So you can write your Ratpack applications, refactor them, reorganize them in such a way that allows you to write these sort of fluent promise chains, right? And it reads really nicely as well. In addition to that, because each of these are method references, which you can also do in Java 8 by using the double colon syntax, it means that each of these methods are also really testable, and it's just easier to read, I find. So we can take a look. This just demonstrates that you can add new posts, and that we can issue against the select star, and we can see that we get our new added to-dos back, right? So there's that. So now here's the thing. So if you start implementing your CRUD endpoints, you'll find that you say, okay, we have a get, which is a select star. We have a post, which will add one and come back. But what you'll quickly find is that you can't just define your endpoints like this. But then because Ratpack is not MVC, we don't build up a routing table, so that we don't know that we have a post and a get until we evaluate the incoming HTTP request, and Ratpack is able to match it up here. So what this means is that because it comes into this, we're actually matching on the path here, which is the root path. And because we explicitly declare this as a get handler, Ratpack says, okay, I found a matching handler, but the method doesn't match. So we're going to issue a 405. So how do we tell Ratpack that we'd like for a given path to handle multiple HTTP methods? This is just demonstrating the 405 here. So this is yet another specification. Specifications are pretty big in Ratpack. It pretty much allows you to configure how your application should behave in a declarative manner, and then Ratpack will execute it according to that specification that you've specified. So in here, instead of doing any kind of HTTP method, you instead say path, and if you do path by itself, it just means path against the root path. So by here, at this point, we will use the by method specification, which is available on the context object, and in here we define our get and post. So if you want to have multiple HTTP methods to be able to handle for a given path, this is the way to do it. So now we can see that our get is our select star and our post is our save to the database. You can see how you can implement the rest of this for put, delete, patch, whatever you want to implement. So when you put this all together, you can see our Ratpack application is starting to grow. This is starting to become longer and longer, and the rest of the notes here just basically go through how do we, as your application grows, how do we evolve it? How do we clean it up so that it still remains readable and easy to reason about? And this is basically going through that. So we have like a to-do based handler that just handles to-dos for any kind of root path kind of stuff. So again, we have our by method specification to allow us to add get, post, delete, and there's also support for options, which is a part of cores here. So for this set, we'd like to tell the client these are the kind of operations that you're allowed to use here, and then we just define delete and we add the delete method here, and then essentially we can extract our base handler into a kind of a chain, right? So you can kind of see this this repeated cadence here in developing Ratpack applications, where you scratch out a bit of functionality, you see that it works, you refactor it, and then you refactor and reorganize and come back to our main application. This is what it ends up looking like. So if we like to make use of these things, we can bind instances into the chain, into your bindings module here. And you can see here that we don't need to necessarily be working with juice in order to add items to the server registry here, which is what each of these methods are doing. So we're adding the new course handler, we're adding the new base handler, we're adding the new chain. And then you can see here, all we need to do here is, in addition to having our course handler, we are now inserting a subchain into our parent chain. So Ratpack allows you the ability to kind of combine chains together so you can start building up request processing logic and functionality. So your Ratpack application now looks like this, and now you have your to-do chain, which then points to your handler, right? So it's a way to keep your code clean and organized. Right, so we go through the same exercise for handling to-dos when you're specified by ID, right? It's kind of the same idea here. The details here aren't as important as the lessons in terms of reorganizing and refactoring your code. But at the end of the day, when you're done refactoring, you need a place to deploy it. And I don't work for Heroku. I'm not affiliated with them at all. I don't get paid to talk about them. But essentially, I like Heroku because you don't really need anything other than an account to be able to quickly prototype your applications and see them and see them in action. So I just have some steps here on how to do that, how to update your Gradle build scripts in order to do that. And essentially at the end of the day, you get your Ratpack application up and running. So, and with Heroku, where this is hosted, I'm using the free instance that they have available. And if there's no activity, it just goes to sleep. So you can see some stuff here, but once this comes back up, once this wakes up, you can see that because we're using H2, the in-memory database, we just get back this empty JSON array. But if we were to come back here, right, so we'll see that this is empty, and then what we can do is come back and see that our application passes all the specifications for the to-do backend. And once this is done, we can see that because of the test ran, we have some stuff here, and we can see that this state is consistent with what we have here. So, if you want to learn Ratpack, visit Danny's GitHub page for notes. We can do these things, right? And we can see that the state is updated here. So that's what I have for you today. And if you're interested, like I have way more notes and more information about testing Ratpack app. You know what? Let me just do that. So if you go to repositories, right. Well, there's also so here's a presentation about testing. If you're using Google Cloud, I just go over how to do that real quick. So the equivalent talk that I just did right now is available in Java flavor. So if you don't use Groovy at all, we can go through all the same stuff in Java. And this is all covered here. So again, if you're interested, please come take a look. There should also be, oh, that's right, I didn't publish those notes yet. Okay, so my async talk is not up on my slides yet, up on my GitHub, but they will be available there sometime later this week. And yeah, if you're interested about testing in the meanwhile, you can come take a look at that. We also have a couple of resources available. So our colleague Dan Woods, who's also part of the Ratpack core team, published a book with O'Reilly earlier last year. It's called Learning Ratpack. It's a really fantastic resource. If you're really interested and kind of interested by what you saw today, you can come take a look. All the proceeds from Learning Ratpack goes back into back to the community. So all the proceeds go to this nonprofit organization called Great Ladies, which is it's not about Groovy in particular, but it's an organization that promotes kind of diversity in technology. So if you buy Learning Ratpack, you're supporting that with the proceeds. We also have an official community Slack. So if you have any questions about how Ratpack works, or just want to see how people are using it in general, you can come take a look and sign up here. This is unresponsive right now, but we have really good turnaround time in terms of if you have any kind of questions in Ratpack, how do I do this? How do I do that? We have really good turnaround time on the Slack. We also have forums available, but the turnaround time on forums are not as quick. Just a fair warning. Oh yeah, here we go. So you can invite yourself to our Ratpack Slack. This is also their official website, ratpack.io. And all of our documentation is available here. Now, I do want to warn you that people tend to complain about our documentation as being sparse. That's true for the user guide. However, the API, the Java doc here is actually really, really well done. And as an example, like if we were to take a look at context object, you can see that we have code snippets in here, right? And a little secret here is that for each code snippet that we have in either documentation, so that's something like, let's take a look at single page. So if you're interested about working with static assets as an example, because we can serve static assets, you can see that we have code samples here, right? As we go through this kind of user guide, all these code tests all these code snippets are actually extracted, compiled, and executed. So all these assertions are actually made before we build and ship with our documentation. So all of our documentation is actually tested, both the user guide as well as the Java docs. So you can see here that we're making asserts, and by seeing these, you're guaranteed that these tests did run and pass before we shipped out these documentation. So that's a pretty cool thing that I find to be interesting. But yeah, other than that, you can always reach out to us individually on Twitter or whatever if you're interested or have any other questions regarding Ratpack. But yeah, that's all I have. So I'll take questions now.
I think we'll just take a couple of questions.
What integration with Swagger?
You got that, Danny? Integration with Swagger.
I'm sorry, integration with what's that last word?
Swagger.
Swagger, okay. I don't have an example of that. I think someone has done an example of either using Swagger or Spring REST docs. But, oh no, you know what? Actually, Guillaume Laforge has an example of that. I don't have one off the top of my head, but if you Google for Guillaume Laforge's, Guillaume Laforge is he's the project chair for Groovy, Apache Groovy project, but you can take a look there. He has some Swagger documentation on working with Swagger and Ratpack and deploying that out to Google Cloud. But yeah, there's he has something with that. Any other questions?
Else?
Okay.
I think it's all good. Okay, thank you, Danny. It's worth noting Danny is presenting from New York, where it's about, what, 5 a.m.?
It's currently 6:50.
Oh, sorry, it's late in the morning. So thank you, Danny, for presenting. Just give you a big round of applause.
Yeah, thanks for having me.
Cheers.